The Moon, our only natural satellite, has shaped Earth in profound ways, yet remains a barren, lifeless world. But how did it come to be? And what role does it play in shaping our planet? In this video, we'll explore the Moon's origins, its effects on Earth, and why it lacks oceans, vegetation and life. By the end, you'll have a deep understanding of just how critical the Moon is to our existence. Let's start with its creation, a violent beginning that set the stage for everything that followed. The most widely accepted theory for the Moon's formation is the giant impact hypothesis. Around 4.5 billion years ago, a Mars-sized body called Theia collided with Earth. The impact ejected a massive amount of debris into space, which eventually coalesced into the Moon. This catastrophic event reshaped both Earth and its new satellite forever. There are alternative theories, like the co-formation theory, suggesting that Earth and the Moon formed together, and the capture theory, which proposes that Earth's gravity pulled in a wandering celestial body. However, the giant impact hypothesis is the most widely accepted because lunar rocks share isotopic similarities with Earth's mantle. The Moon is essentially made of the same materials as Earth's outer layers. Over time, the molten Moon began to cool. Its crust solidified, and asteroid impacts created massive basins and craters. Volcanic activity also played a role, shaping the surface we see today. The Moon is about 3,474 kilometers in diameter, roughly 1/4 the size of Earth. Despite its size, its mass is much smaller, giving it only 1/6 of Earth's gravity. If you weigh 180 pounds on Earth, you'd weigh just 30 pounds on the Moon. This low gravity has significant effects on how materials behave and how astronauts move on its surface. The Moon is primarily composed of silicate rock with a crust, mantle, and a small iron core. Its surface is covered in regolith, a fine lunar dust created by billions of years of asteroid impacts. Unlike Earth, the Moon lacks plate tectonics, which means its surface has remained largely unchanged for millions of years. Lunar craters are among its most prominent features. These craters, some stretching hundreds of kilometers wide, tell the story of a violent past. With no atmosphere to erode them, these scars from impacts remain visible indefinitely. Another striking feature of the Moon is its maria, large, dark basaltic plains formed by ancient volcanic activity. Though they appear smooth compared to the heavily cratered highlands, these plains are the result of magma flows from the Moon's fiery past. The Moon's gravitational pull is responsible for Earth's ocean tides. This interaction is crucial for marine ecosystems and has played a role in the development of life. Without the Moon's influence, tides would be much weaker, altering coastal environments dramatically. Additionally, the Moon stabilizes Earth's axial tilt, preventing extreme climate fluctuations. Without it, our planet's tilt could shift wildly, causing chaotic weather patterns. Over millions of years, this stability has allowed life to thrive. Over time, the Moon is also gradually slowing Earth's rotation. As it transfers angular momentum away from Earth, our days lengthen by about 1.4 milliseconds per century. This change might seem small, but over billions of years, it has significantly affected Earth's climate and biological evolution. Unlike Earth, the Moon has no atmosphere. This means there's no wind and no weather, and no protection from harmful solar radiation. The lack of an atmosphere also results in stark temperature extremes. Because there is no atmospheric pressure, liquid water cannot exist on the surface. However, ice has been found in permanently shadowed craters at the Moon's poles. Scientists are particularly interested in these ice deposits, as they could provide a valuable resource for future lunar missions. Temperatures on the Moon are extreme. During the lunar day, temperatures can reach 260 degrees Fahrenheit, while at night they plummet to minus 280 degrees Fahrenheit. These harsh conditions make it impossible for life as we know it to survive. Any potential colonization efforts would require advanced technology to shield inhabitants from these extremes. Another key difference from Earth is the Moon's lack of a magnetic field. Without it, solar wind continuously bombards the surface, stripping away any chance of a long-term atmosphere. This is another reason why the Moon has remained lifeless. Some people believe the Moon landings were faked. However, we have overwhelming evidence proving otherwise, including retroreflectors left on the surface, high-resolution images from lunar orbiters, and first-hand accounts from astronauts. Have you ever noticed that the Moon seems larger at certain times? This is due to its elliptical orbit around Earth, making it appear bigger or smaller depending on its position. The Moon is also slowly drifting away from Earth by about 3.8 centimeters per year. Over millions of years, this will have a significant effect on our tides and Earth's rotation. There is also the phenomenon of tidal locking, which is why we always see the same side of the Moon. The Moon rotates on its axis at the same rate that it orbits Earth, making one hemisphere perpetually hidden from view. To summarize, the Moon, formed through a massive collision, plays a crucial role in stabilizing Earth's environment and remains a lifeless, barren world due to its lack of atmosphere and magnetic field. In the future, the Moon may become home to human exploration and even permanent bases. Scientists continue to study its mysteries, uncovering new details about its past and potential future. Though the Moon may seem distant and unchanging, its influence on our planet is profound. Without it, Earth would be a very different place. And as we continue to explore beyond our home planet, the Moon will likely serve as our stepping stone to the rest of the cosmos. Thank you for watching. If you enjoyed this deep dive into the Moon's secrets, be sure to like, subscribe, and stay tuned for more space explorations.